students, I welcome you all in this session. As you are aware, in previous session we were discussing about hypothesis testing of proportion, and we have worked out couple of examples as well. In today's session we will look at few more examples on hypothesis testing of proportions, 2 samples, and we will work out using these examples through critical value approach as well as prob value approach. So, let us look at this example, quite an interesting one. A large hotel chain is trying to decide whether to convert more of its rooms to non-smoking rooms. So, in a hotel you have got smoking rooms and non-smoking rooms. So, the hotel chain is trying to decide whether should it convert its smoking room to non-smoking room or not, right. So, in a random sample of 400 guests last year, 166 had requested non-smoking rooms. So, out of 400, 166 requested for non-smoking rooms, right. This year 205 guests in a sample of 380, 205 in a sample of 380 requested or preferred non-smoking rooms. Now, what would you recommend, that the hotel chain convert more rooms to non-smoking? Support your recommendations by testing the appropriate hypothesis at 0.01 significance level, right. So, this is quite an interesting example, and you should know how to frame a null and alternative hypothesis, because in this case the hotel wants to know should it convert its smoking room to non-smoking rooms or not. So, there are different ways in which you can frame null and alternative hypothesis. So, let us look at it in this way. So, let us say P1 is equal to P2, right. The proportion of guests who preferred non-smoking rooms last year, and proportion of guests preferred non-smoking room in 2000 let us say this year, right. Now, when the hotel should convert its smoking room to non-smoking room, there is only one condition. The hotel should convert its smoking rooms to non-smoking rooms when hotel is ensured that there are more and more non-smokers coming in the hotel, right. So, if that hypothesis is proved, that more and more non-smokers are coming, if this hypothesis is proved, then hotel should convert its smoking rooms into non-smoking rooms. Or in other words, we can say that if let us say if number of smokers are reducing, then also the hotel should convert its smoking rooms to non-smoking rooms. So, let us say its null hypothesis is this, that the number of smokers and let us say number of non-smokers are same, right. There is no change in this proportion. So, alternative hypothesis can be, let us say P1 less than P2, right. What is P1? The non-smokers who requested rooms last year and non-smokers preferred rooms this year, right, that is P2. So, if we say that the non-smokers were less previous year, and if we accept this hypothesis, it means the hotel should convert its non-smoking rooms to its smoking rooms to non-smoking rooms. Once again, if this hypothesis is true, or if we do not reject this hypothesis. If we accept this hypothesis, it means that the non-smokers in earlier years were less than this year. Okay. So, let us look at this approach first. So, null hypothesis is, let us say this, both these proportions are same and this P 1 is less than P 2. What is P 1? Is the proportion of non-smokers last year less than proportion of smokers, non-smokers this year, right, at alpha is equal to 0.01 significance, right. So, how did you get this one, this value 0.415? You just got it by, let us say it is 166 by 400 and 205 by 380. That is how you would be getting 0.415 and 0.5395. So, let us look at this standard error, difference of standard error of population proportions, it is 0.0358. Now, since this is a case of left tail test, right. So, this is left tail test. So, this is your rejection region alpha. Okay. So, its value in table or z value in table is minus 2.33. Okay. And the calculated z value is this. So, we will reject null hypothesis. It means this is the critical value which is minus 2.36, sorry 33, minus 2.33, and calculated value is somewhere here minus 3.48, let us say here, which is in rejection range. So, we will reject the null hypothesis. We will reject null hypothesis, we will reject this. It means we accept this, we accept the, it means the proportion of non-smokers were lesser in earlier year than this year. It means we should convert, the hotel chain should convert more rooms to non-smoking, because there was a significant increase in proportion of guests requesting non-smoking rooms. So, let us work out this example. In fact, you can work out this example in other way as well. So, first let us solve this question using Minitab. Okay. So, let us look at this. So, this is a case of hypothesis testing of proportion 2 samples, right. So, go to state basic statistics, it is 2p, 2 proportions, right. So, we have to have summarized data. So, number of events and number of trials, right. So, number of events, let us look at question. It is 166 out of 400, 166 400. For second sample, it is 205 out of 380. Options. So, this is hypothesis testing is at 99% significance level, hypothesized difference is 0, and this has to be an alternative hypothesis, has to be a less than type of hypothesis, right. So, use pooled estimate of the proportion and then click. So, this is our calculated z value minus 3.48, which is same as this, just see minus 3.48, right. And if you look at p value is 0. Let us compare p value with alpha value. So, p value is 0, 0.000 and so on, alpha is equal to 0.01. So, p is less than alpha. So, we will reject null hypothesis, is not it? Reject H naught. The moment we reject H naught, we accept alternative hypothesis, and in alternative hypothesis we are saying that the proportions of non-smokers in previous years were more than this year, right. So, or in other words, the proportion of non-smokers more than proportion of non-smokers in last year, right. So, we should convert more of hotel rooms to non-smoking rooms, right. Let us work out the same example using different approach. So, this is in fact nothing but the percentage of people who preferred non-smoking rooms, right. So, when I say these are non-smokers, so smokers would be, let us say smokers would be 0.59 something, is not it, 0.59, and what about this, it is 0.43. So, it is 0.47 something, is not it, because 1 minus this would be this and 1 minus this would be this. So, let us look at this question in this way. Last year these many smokers were there and this year this many smokers were there. So, we can frame null hypothesis like this, P 1 is equal to P 2 and the P 1 greater than P 2. The number of smokers in last year were more than number of smokers this year, right. Let us look at how whether do we reject or we do not reject null hypothesis and right. So, just keep in mind this is 0.59 and this 0.47. So, we will work out this example. So, we will go to state basic statistics 2p. Yeah. So, number of events would be just 400 into 0.49, what it was 0.59, right. So, this is 234. Similarly, in second case it is 175, right. So, we will say that proportion of smokers last year and proportion of smokers this year. Okay. Okay. Go to options and this is let us say greater than type. Okay. Again P is equal to 0. So, we will reject null hypothesis. We will reject null hypothesis again here. It means we will say that the last year the non-smokers were more than this year, right. So, this is how you can solve an example on hypothesis testing, right. So, let us look at next question. Let us say the income tax department wants to have more and more returns, people should file more and more income tax returns. So, there are two methods. The first is either people can go to the office personally or they can send their returns through mail methods, right, through email, right. And the income tax department thinks that the personal method of filing in income tax returns will have fewer mistakes than mail method. So, how would you frame null and alternative hypothesis? So, you have got let us say P 1 is equal to P 2, right, and P 1 is less than equal to P 2, right. So, let us work out this example using Minitab. So, keep in mind this is 50 and this would be 10 and this 75 and multiply these two would be the number of events in this case, right. So, we will go to stat, basic statistics 2p. So, this is 50 and this would be 10, 5, right, because that is, that value is just 0.100, right. So, 75 is the second case. So, this is 75 and you will have number of events as 10, right. We will go to options. This is at what significance level? Okay, it is 0.15. So, it is 85%. Difference hypothesis is less than type, right. So, this is the alternative hypothesis. Okay. Again okay, right. So, p value is 0.28. So, p value is 0.28, alpha is equal to 0.15. Is p less than alpha? No. So, we do not reject null hypothesis. So, we do not reject null hypothesis, it means the both these methods are equally good. The personal method does not decrease mistakes, right. So, they are equally effective, whether it is personal appearance or Mel method. Let us look at hypothesis testing for variances. So far we have seen hypothesis testing of means and hypothesis testing of proportions, right. Let us look at hypothesis testing of variances. So, you have got two populations and you want to test whether their variances are same or not, right. So, for this we will use something called F statistics, which is the ratio of variances of two sample sizes, right. So, you can have test for population variances, you can have hypothesis testing like this, alternative like this, and you can have alternative hypothesis like this, is not it. So, where we all know that S1 square is variance of samples, first sample, N1 is you can have number of units in first sample or sample size for first sample, and 2 is sample size for sample 2, S2 is variance for second sample, N minus 1 is numerator degrees of freedom, and N2 is N2 minus 1 is denominator's degree of freedom, right. So, let us look at this test. So, we have to find out critical value from table, F table, and we need to compare those F table values with the F statistics which we calculate using this formula, which is ratio of these two variances. But the F table we get value at numerator degrees of freedom and at denominator degrees of freedom, right. So, this is how the distribution looks like. So, null hypothesis is that these two distributions are equal and they are not equal. So, this would be rejection region, right. So, this is a two-tailed test, right. This is your non-rejection region. Similarly, this is an upper tail test, you have got just one rejection region, because alternative hypothesis is this sign is greater than type. So, this is your rejection region. So, let us look at this question. You are a financial analyst for a brokerage firm. You want to compare dividend yields between stocks listed on the New York Stock Exchange and Nasdaq. You collect the following data. So, 21 stocks from here and 25 stocks from Nasdaq, and standard deviation 1.3, 1.16. Is there a difference in variance between these two? Though we have been given a standard deviation, we can easily convert a standard deviation into variances, right. So, we just want to know is the variance of these two samples same. So, you need to frame null and alternative hypothesis, right. So, let us look at this. So, this is your null hypothesis that there is no difference and there is a difference. So, it is a case of two-tailed test and at significance level 0.05. So, at numerator degrees of freedom and at denominator's degree of freedom, we need to look at f value from table, right. So, let us look at the table value. So, this is the table, your alpha is 0.05. So, look at this table. Okay. Now, how to look at f value in table, right. So, first of all you got numerator degrees of freedom which is for sample 1, right. So, sample 1 is of size 21. So, 20 numerators degrees of freedom and sample 2 is denominator degree of freedom. So, n2 is 25. Okay. So, 25 minus 1 24. So, what we want to know? We want to find out f value at 20 degrees of freedom of numerator and 24 degrees of freedom of denominator, right. So, 20 and 24. So, these are numerator degrees of freedom, this row wise and this column is denominator, right. So, what we want? 20 numerator and 24 denominator, right. 20 numerator. So, this numerator, so this 20 numerator, right, and 24 denominator, 24 is this. So, this is the value 2.33. So, we will get, because this is a two-tailed test, you will have to find out two values of f, two critical values of f. It is not like hypothesis testing of means or proportion where just one value would be sufficient for left side and right side. Here for left and right side you will have to have two f critical values. So, the first f value is 2.33, right. Now, this is what we have calculated, 2.33, which is this. So, this is the upper limit, upper critical limit. Now, you need to find out lower critical limit as well. So, for that what you need to do is this, it is very simple. Since you have already calculated this, right. So, to calculate lower critical value, what you have to do is this, 1 upon this, you need to just change the degrees of freedom. Just see, here it was 24 degrees of freedom, numerator, this was numerator, this was denominator. Now, just change these two to this is now numerator and this is denominator. So, we will just change the degrees of freedom. Now, let us look at the same table when 24 degrees of numerator and 20 degrees of denominator. So, 24 numerator, we will go to same table, right, 24 numerator, right, 24 numerator and 20 denominator. So, this is the value 2.41. So, 1 divided by 2.41 will give you lower critical limit. Okay. So, now you have to see whether this ratio is in this limit or not. If it is in this limit, we do not reject null hypothesis, otherwise we will reject null hypothesis. So, in this case, if you look at our lower limit is 0.41, upper limit is 2.33 and calculated f value is 1.256, which is in between. So, we will not reject null hypothesis. We will not reject null hypothesis. It means what? It means what? It means that the variances of these two stocks are same, one and the same thing, right, there is no difference in variances. However, if you look at this standard deviation, you will say that variance of this would be higher. No, it is not like that. Statistically, these two variances are exactly same, there is no difference. So, we will work out this example using Minitab. So, we will go to state, basic statistics, we will go to two variances, right. So, we will have sample sample standard deviations. So, we have sample size, it is I think 21, just check, we will check it, 21, 1.3 and 25, 1.16. We will go to options, at what confidence level we have to test, at 95% significance level. So, it is 95, hypothesize ratio is 1, right. We want this to be 1. If this ratio is 1, it means we will not reject null hypothesis, right. Okay. So, let us look at this ratio is not equal to hypothesize ratio, we will use again. So, let us look at p value over here, this is the p value, right. In this case, if you look at, so at 21 degrees of numerator, 24 degrees of denominator. So, p value is 0.58. So, this p value is, if you look at carefully, p value is 0.589 and here it is 0.05. So, p value is more than alpha. So, we do not reject null hypothesis, we do not reject null hypothesis. We do not reject null hypothesis, it means they are one and the same. Okay. We will try one more example, and let us say there are two types of anesthetics and we want to find out the effectiveness of these two. So, when anesthetic, this one Orelcaine was given to 31 patients, the sample variance was this, or this was the sample variance for second anesthetic, sample size was 41 and sample variance was 784, right. So, can we say that these two anesthetics are one and the same thing, are they equally effective? In other words, can we say that sample variances are same? So, this is your null hypothesis and this would be your alternative hypothesis, right. So, similar to previous example, we can work out upper limit and lower limit for this as well, and since the calculated f value is in non rejection region. So, we will not reject null hypothesis and we will say that there is no sufficient evidence of difference in variances at 0.02 alpha. So, let us look at this question using Minitab. So, go to state, basic statistics, two variances, right. So, sample size is 31 and 1296. In fact, rather than this we can change this to variance, right, a sample variance, right. Otherwise, you will have to just square it and write down their values, right. So, variance for first sample is 1296 and for 41 it is 784, it is 784, right. We will go to options, it is 0.02, yeah. So, it is 98% significance level and of course alternative hypothesis will remain same, it is not equal to type. So, we will press OK and again OK. Let us look at p value. P value is 0.137, p value is 0.137 and alpha is equal to 0.02. So, p value is greater than alpha. So, we do not reject null hypothesis. Now, this is the way in which you can work out examples. In fact, the lower and upper critical limits can be obtained from this table. Similarly, you can work out this example as well. So, you have been given let us say 2 groups, sample size 21, here sample size 25 and you have been given sample standard deviation. So, we just want to know, is earning of these 2 groups same, is there any difference between earning of these 2 groups, right. So, you can work out this example using Minitab or by critical value approach. So, with this let me complete today's session. Thank you very much.